In the last segment, we worked on looking at reactions, figuring out what type they were, figuring out what the valid products were, and or figuring out how to balance. On the next page, we had 3 more, so I started them for you for the purposes of moving along. Again, you may wish to pause, or you can follow along. This one's going to be combination. Again, you have to remember that hydrogen and oxygen are diatomic. Otherwise, it will never balance. The next one is going to be double replacement, which means you need to separate your ions and pair them and make a valid product. 2 and 3 always makes 6. So we're going to have 3 zincs, 2 phosphates for ZN3PO4 2. And if you don't get that right, then you spin your wheels balancing all day long. K plus and Br minus, you go by the charge. Makes KBr. 2 and 3 is always code for 6. 6 potassiums, 6 bromines. And shazam, you're done and you're balanced. 3 zincs, 6 bromines, 6 bromines, 6 potassiums, 2 phosphates, 2 phosphates. The last one is also double replacement, which means you have to separate these into their valid ion forms. And anytime you do this, this means this has to be aqueous. This has to be dissolved in water. So our iron 2 with our hydroxide means we need 2 hydroxides, which means FeOH2 is our valid product. NaNO3, it doesn't matter that we have 2 of them. We're going to fix that in a minute. NaNO3 is our product. 2 sodiums in, 2 sodiums out, 2 hydroxides in, 2 hydroxides out, 1 iron in, 1 iron out, 2 nitrates in, 2 nitrates out. Again, practice. Okay. Now, what else might we be interested in here? Well, we're interested in what we might see or experience in the lab. Now, specifically with double replacement, this should not be new either. Oftentimes, we want to know if we see a solid forming. An aqueous plus an aqueous yields a solid if the product is insoluble, and this is called a precipitate. And where do you go look to see if something is soluble or insoluble? Well, you look at a solubility table. And again, you should have a solubility table handy in order to do this. Okay, so let's go back and see if we can figure out if we're going to have a precipitate. So page 5. Not an aqueous plus an aqueous. Not an aqueous plus an aqueous. Nope, wrong type. Nope, wrong type. Nope, wrong type. Nope, wrong type. Nope. This, however, is aqueous plus an aqueous. And we look at our solubility table and we see that the zinc phosphate is insoluble, which means that is a solid. And therefore, this will also be a precipitate. This one is an aqueous plus an aqueous. We know that because we've dissociated ions into solution. We look at our solubility table and we see that the iron 2 hydroxide is insoluble, which means that is solid, which means this is our precipitate. Okay? Now again, you're going to want to go and practice. Okay? Practice, pause, go to your book, try problems there, try handouts, go back to old labs, go find whatever's on Blackboard. There should be ample examples in how to do this. Okay? Now the other thing that you might be looking for, experiencing, is something that will be either a gas evolving, which you can see, or heat forming, which is something that you feel. Now one of these is an acid-base reaction. And an acid in general is recognized by a hydrogen on the left-hand side. Okay, so H2SO4, HCl, HNO3, HCH3CO2, etc. Okay, how do you recognize a base in general? Has an OH. Okay, so the easiest definitions are these. So NaOH, CaOH2, LiOH, etc. Okay, so when you have an acid-base reaction, you typically generate heat. Okay, so acid-base will generate heat. Acid-base, we would expect heat. Acid-base, we would expect heat. So these are also double replacement. Li plus, OH minus, H plus, Cl minus. They're aqueous. All of these that we dissociate are aqueous. LiCl, H2O. We look at our solubility table. We see lithium chloride is soluble, which means that's aqueous. Water is water, which means it is liquid. So we're going to see no precipitate, but we will feel heat. Same thing here. K plus, OH minus, 2H plus, SO4 2 minus, K2, SO4. We need 2 of those in order to make that valid. H2O, 2 waters to balance. Look at our solubility table. Group 1 compounds are all soluble. So this is going to be aqueous. So there's going to be no precipitate, but this is an acid, this is a base, so we're going to expect to feel heat. Okay? Now sometimes you just expect to see a gas, and these are special situations, and you're just going to need to recognize this when you see it. 2Na plus, SO3 2 minus, H plus, Cl minus, gives us NaCl, H2, SO3, and we would think we were done. Except that this is a special acid that decomposes, and so you just need to remember this when you see it. 2NaCl, H2O, and SO2, which is a gas. Okay? H2SO3 will always decompose. If you take out water, 2 hydrogens, 1 oxygen, you get SO2, which is a gas. Okay, and then the last one on the list, Na plus, CO3 2 minus, H plus, NO3 minus, NaNO3, very straightforward, H2CO3. Okay, so this is another special one that is also going to decompose. H2CO3, whenever you see that, it's going to decompose into water, take out 2 hydrogens, 1 oxygen, CO2. Okay? So we're going to get 2 NaNO3 plus H2O plus CO2, which is a gas. Okay? All right, so again, continue to practice, and in the next segment, we'll continue talking more about what you would experience in the lab.